Let's learn what square roots are. Calculating a square root is an inverse operation of squaring, or the opposite operation of squaring. For example, we know that 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, and so on. That means when you calculate the square of 2, you get 4, or you calculate the square of 3, you get 9. Whereas the square root is the other way around. That means the square root of 16 is 4, the square root of 9 is 3, the square root of 4 is 2, and so on. So that means it is the opposite operation. 4, 9, 16, 25, all these are square numbers, right? All these are perfect squares. So the root of these perfect squares, or the root value of these square numbers, is called as the square root. And this symbol shows the square root. The symbol that looks like a tick mark, this is the symbol for square root. We know that this is how we write 5 squared equals 25. We write this little 2 above 5. That's the symbol, or that's the sign for squaring. When you write this symbol like the tick mark, it says the square root. Now here it says the square root of 25, which equals 5. How do you calculate a square root? This is what you should think. You should ask yourself, what number should I multiply by itself to get this number? For example, if you want to calculate the square root of 100, so you should ask yourself, what number should I multiply by itself to get 100? Now what is that number? You know that 10 tens are 100. That means you should multiply 10 by 10 to get 100. That means 10 is the square root of 100. This was easy because this is an easy number to calculate square root. But is there any method so that we can calculate square roots of big numbers or little difficult numbers as well? Yes, there is a method called as prime factorization. You know what is prime factorization. We have used prime factorization for calculating LCM and HCF. Let's use prime factorization for calculating square roots. So let's start with 100 because it's an easy number. Divide by 2, so you get 50. Divide by 2, you get 25. 25 is not divisible by 2, is not divisible by 3. So the next prime number is 5. Let's divide by 5, you get 5. 5 is a prime number, so we stop. That means the prime factors for 100 are 2 multiplied by 2 multiplied by 5 multiplied by 5. Now what we do is we pair the numbers. You can see that each number appears twice in the prime factors. So you pair the same numbers and take only one number from the pair and multiply. That means you can see that there are 2 2's and there are 2 5's. So take 1 2 and 1 5 and multiply. 5 2's are 10. So 10 is the square root of 100. You can see that 5 multiplied by 2 gives you 10. And when you calculate the square, you multiply 10 by 10. That means you multiply 2 by 5 with yet another 2 by 5. So in 10, you multiply 2 and 5 and you get 10. In 100, you multiply 2 by 5 and again multiply that by 2 by 5. That means you multiply 10 by 10 and that's how you get 100. This is how the prime factorization helps you to find the square root. Let's take another example, 441. Let's do the prime factorization of 441. 441 is not divisible by 2. Let's divide by 3. When you divide by 3, you get 147. 147 is again divisible by 3. Divide by 3, get 49. 49 is not divisible by 2, 3 and 5. So divide by 7, you get 7. 7 is a prime number, so you stop. So the prime factors are 3 multiplied by 3 multiplied by 7 multiplied by 7. You can see there are 2 3's and 2 7's. So we pair these factors and take 1 3 and 1 7 from these pairs, multiply that, we get 3 7's are 21. So 21 is the square root of 441. Let's try to find the square root of 72. Again we start with prime factorization. Divide by 2, you get 36. Divide by 2, you get 18. Divide by 2, you get 9. 9 is not divisible by 2, so divide by 3, you get 3, and now we stop. So the prime factors are 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3. Let's try to pair the factors. So you get it like this. Now you have one pair of 2's and you have one pair of 3's, but then you see this 2 here which doesn't have any partner to pair with. That means 72 is not a perfect square. It is not a square number. We know that 8 8's are 64 and 9 9's are 81, and 72 is in between 64 and 81. That means the square root of 72 must be somewhere between 8 and 9, but it is not a whole number. So the prime factorization also helps me to figure out whether a given number is a perfect square or not. And this is how I know that 72 is not a perfect square. Is there any other method I could use to figure out that 72 is not a perfect square? Yes. I can see that in the units place, the digit is 2. This number ends with 2. That means it is not a square number. We know that if any number ends with the digit 2, it will not be a perfect square. So I can just look at the number 72 and I can say that it is not a perfect square.